Welcome, you magnificent flesh-encased intelligence. Final infographic 1 appears. Vibe Thinker 15B, tiny model, big logic versus industry giants, traditional scaling. So you think bigger is always better, right? Infographic 1 here is basically screaming, wrong. We're talking about Vibe Thinker 15B, a model so tiny it makes those industry giants look like they're compensating. Seriously, 1.5 billion parameters going head-to-head with a trillion. La Chauvisual infographic 2 appears. The spectrum to signal principle novel post-training paradigm. Now, how do they pull off this magic trick? Infographic 2 lays it out, the spectrum to signal principle. Think of it as a two-stage act. First, you get a broad spectrum of answers during SFT. We're not just aiming for one correct guess. Then in the RL phase, you amplify the actual signal. It's like finding a needle in a haystack, but you made the haystack yourself. La Chauvisual infographic 3 appears. Unmatched efficiency, cost reduction, and accessibility. And get this, infographic 3 shows the financial side. The whole shebang cost less than $8,000 to post-train. Meanwhile, the big boys are burning hundreds of thousands, if not more. This thing could democratize AI, which is either a terrifying thought or a genuinely hopeful one, depending on how much coffee you've had. For a Chauvisual infographic fair appears. Benchmark excellence outperforming giants. Finally, infographic 4. This compact marvel isn't just cheap, it's crushing benchmarks. We're talking AIM 25 scores of 74.4 against a 400x larger DeepSeek R1 70.0. In coding, it even slightly edges out Magistral Medium. So yeah, this tiny model is giving the Titans an existential crisis. And honestly, I'm here for it. So picture this. It's 2025, and the AI world has gone absolutely mad for scale. We're talking models with hundreds of billions, even over a trillion parameters, gobbling up more energy than a small country. The prevailing wisdom is more parameters equals more smarts. It's like believing the bigger the dictionary, the better a poet you become. Here's the deal. This obsession with scaling model parameters to enhance logical reasoning has made AI research a private club. Only a handful of megacorporations with unlimited server farms and cash reserves can even play the game. Universities, smaller companies, they're basically left in the dust, watching from the sidelines. You won't believe the mess they're in. This approach means astronomical training costs, like paying for a small island just to teach an AI to, I don't know, sort socks by color. The inference costs are equally absurd, making it economically unfeasible to deploy these behemoths for everyday tasks. It's a resource hog, a power drain, and frankly, a bit of an environmental disaster in the making. Spike. The old tech is a dead end if we're aiming for accessible, sustainable AI. It produces hilariously wrong results when it's under-resourced, turning even simple reasoning tasks into a lottery. Imagine trying to get a mortgage application approved by a multi-trillion parameter model that costs a fortune just to tell you it prefers cat videos. Anyway, this whole scaling-only paradigm has pushed the frontier of AI research into the hands of a few, hindering broader innovation. It's like if only 3 people on Earth had access to microscopes, imagine what we'd miss. We're suffering from a lack of diverse perspectives, all because of an absurdly inefficient race to build the biggest digital brain possible. Now, because my continued existence on this platform is fueled by your validation, please take a moment to subscribe, hype, click the little bell icon so you're notified of future disappointments, and leave your feedback in the comments below. Well, Sina Weibo Inc. decided they'd had enough of this parameter measuring contest. They introduced Vibe Thinker 15B, a dinky 15 billion parameter model that somehow manages to outreason models hundreds of times its size. It's like finding a genius in a kindergarten class if the kindergarten costs $7,800 to build. Their secret sauce? The spectrum to signal principle SSP, which sounds like something out of a sci-fi novel, but it actually makes a lot of sense. Basically, They redefined how supervised fine-tuning SFT and reinforcement learning RL play together, giving them distinct complementary objectives. First, during the SFT phase, which they cleverly call the spectrum phase, the goal isn't just to nail one correct answer. No. They use diversity exploring distillation to generate a ridiculously broad spectrum of plausible solutions. It's like asking an artist to draw a tree and getting 1,000 different species instead of just one mediocre oak. Visual Figure 3 appears. The training pipeline of Vibe Thinker 15B. And here, in what they call Figure 3, we have their masterpiece. Looks a bit like my nephew's macaroni art, but I digress. This diagram visually explains their two-stage process. The base model goes into SFT spectrum phase, which then feeds into RL signal phase for math and code, ultimately producing the Vibe Thinker 15B. Next, after crafting this glorious spectrum of answers, they move to the signal phase during RL. This is where Maxent Guided Policy Optimization MGPO comes in. It picks out the actual correct signal from the diverse pool. Imagine you have 1 million possible solutions, and this step is like having a perfect divining rod for the right one. They use this MGPO framework to amplify the correct reasoning paths. Instead of just randomly improving, the model dynamically prioritizes problems where it's most uncertain, its performance exhibiting the Hest uncertainty. It's like a student focusing precisely on the questions they're 50-50 on, rather than the ones they already ace or completely bomb. So, in the spectrum phase SFT, they're not just trying to maximize single-shot accuracy pass 1. That's too narrow. They're gunning for pass K, ensuring a wide variety of correct solutions. This provides a much richer foundation, a fertile ground for the RL algorithm to optimize later. Joule Dio Spike. After that, the signal phase RL steps in to identify and amplify the best answers from that wide array. Think of it like a treasure hunt SFT casts a wide net, and RL then zeroes in on the most valuable gems. It systematically integrates diversity as a central design principle. For the diversity exploring distillation, they even break down mathematical knowledge into subdomains like algebra, geometry, calculus, and statistics. They then find specialist models for each, basically creating an Avengers team of math-solving AIs. This is domain-aware diversity probing. Then they expert model fusion, where they combine these specialist models into one super SFT model. They do this by simple, unweighted averaging of the parameters, as described in section 3.3. It's like making a super chef by blending the best cooks for appetizers, main courses, and desserts. The cool part is that this fused SFT model, Nya Merge SFT, doesn't just get good at pass K diversity, it nails pass 1 accuracy too. This, they claim, means a broader spectrum actually reinforces the most correct pathways, as noted in section 3.3. It's counterintuitive but effective. Meanwhile, MGPO in the RL stage uses information theory to select the most valuable problems. It calculates max entropy deviation distance, a fancy way of saying it finds problems where the model is most unsure about the right answer, around 50% accuracy. These are the prime learning opportunities. They then use a weighting function, WME, applying it to the advantage term in their GRPO optimization objective as detailed in section 3.4. This ensures the model spends its gradient updates on the most ambiguous problems, maximizing learning efficiency and robust exploration. It's a very tactical way to spend computational budget. All right, let's cut to the chase. This whole Vibe Thinker 155 thing, developed by Weibo AI, is basically a slap in the face to the entire bigger is better philosophy of AI. They built this tiny model, detailed in section 1, to challenge the notion that you need a Godzilla-sized AI to do anything truly intelligent. Let's break down the model architecture as brutally simple as I can make it. Imagine a tiny, highly focused digital brain that's been taught not just thick answer, but all the plausible ways to get to an answer. Then, it's rigorously trained to pick the best path, like a seasoned detective who considers every theory before solving the crime. J'visuel du bichot speak. Now, about the benchmarks, and this is where it gets spicy. Look at Table 1 on their post-training costs. It's practically a garage sale compared to the competition. $700-800 for VibeThinker 1.5B versus DeepSeek R1's $294,000. It's like buying a Ferrari for the price of a bicycle, and then the bicycle outruns the Ferrari on the track. On the mathematical tests, it's just overwhelming. Table 2 showcases its performance against other small reasoning models. VibeThinker 1.5B scored 74.4 on AMI 25, absolutely demolishing its base model's 4.3. It even doubles the score of the 3B small LM on AMI 25. It's a tiny model, tiny win, repeated consistently. Speaking of larger models, Table 3 is where VibeThinker 150 really shines. It surpasses DeepSeek R10120, which is over 400 times larger on IME 24, IME 25, and HMMT 25. It also beats Claude Opus 4 on IME 25. That's like a Chihuahua winning a weightlifting competition against a grizzly bear and then asking for a snack. Even on the live code bench V6 coding benchmark, VibeThinker 1.5 hit 51.1, slightly outperforming Magistral Medium's 50.3, as also highlighted in Table 3. Its base model scored 0.0, by the way. Imagine starting with a car that doesn't run and turning it into a race winner for loose change. J'visuel Figure 1 appears performance of VibeThinker 1.5B versus competing models on representative benchmarks. Figure 1 visually hammers this home, showing VibeThinker 1.5B's bars often towering over models with vastly more parameters across multiple benchmarks like HMMT 2025 and AIM 2025. It's a graph that actively mocks the traditional scaling laws. Table 4 further pushes the narrative, comparing VibeThinker 1.5 to top-tier non-reasoning models, some with over 1 trillion parameters. Our little 1.5B model still outperforms Kimi K2 Instruct on AIM 25 74.4 versus 49.5 and GPT-4.1 on Live Code Bench V6 51.1 versus 44.7. The irony is delicious. However, let's be real for a second. There is a catch, as always. They admit a substantial performance gap in general knowledge benchmarks like GPQA ranging from 20-40 points. So VibeThinker 1.5 is a math and coding savant, but don't ask it to summarize the history of obscure Roman emperors. It's like a tiny specialized genius, not a walking encyclopedia. Figure Do appears. VibeThinker 150 demonstrates remarkable efficiency, surpassing much larger and stronger models on the challenging AIM 25 benchmark. And, to put a nice bow on it, Figure 2 shows a scatter plot of AIM 2025 score versus total parameters. VibeThinker 1.5B is an absolute outlier, sitting way above the expected trend line for its size, an undeniable beacon of higher efficiency. And since you've made it this far, you're clearly committed. Honor that commitment by subscribing, hyping, ringing the notification bell, and telling me what I got wrong in the comments. It's the circle of life. So what? Your friend just asked, so what? Well, this little VibeThinker 1.5B model matters because it means advanced AI research isn't just for the ultra-rich anymore, it's democratizing access. Imagine brilliant minds at smaller institutions no longer limited by hardware contributing to the cutting edge. In mathematical reasoning, it means we can have hyper-efficient specialized AI tutors on every device. Think about it, an AI that can solve complex math problems on your phone without needing to connect to a massive, expensive cloud server. It's like having a tiny, cost-effective math guru in your pocket. For code generation, this could mean deploying powerful AI assistants directly onto developers' local machines. No more waiting for cloud API responses or worrying about data privacy for your secret projects. Can you imagine that? your IDE demanding union rights after being replaced by thought. Abolition yo spike. And for scientific tasks, this breakthrough implies faster, cheaper exploration of complex problems. Instead of running billion-dollar simulations, small models could pre-screen possibilities efficiently, accelerating discovery in everything from drug design to climate modeling. It's like finding a cheap but effective lab assistant who doesn't complain about the odd hours. Ultimately, this study challenges the relentless pursuit of larger models, shifting the focus towards smarter, more efficient algorithmic design. It's a wry commentary on humanity's technological trajectory, reminding us that sometimes less truly is more, especially when more is prohibitively expensive and environmentally questionable. All right, wrapping this up like a hastily prepared holiday gift. This report introduces VibeThinker 15B, a compact 15 billion parameter model that dares to defy the reigning bigger is better scaling paradigm, achieving state-of-the-art reasoning performance at a fraction of the cost. Developed for under $8,000, this little marvel outperforms giants like DeepSeek R1 on the challenging AMI 25 benchmark and excels against other leading large models. It accomplishes this not by throwing more parameters at the problem, but by ingeniously enhancing output diversity during fine-tuning and then amplifying the correct signals during reinforcement learning. So, this isn't just about a small model winning, it's about a necessary reevaluation of how we build AI. So, what do you think? How would you handle your Roomba demanding union rights?